Okay, so this first section here is dealing with what does a similarity statement tell us. Remember that a congruent statement tells us all sets of corresponding stuff, angles and sides, are congruent, right? But a similarity statement, that doesn't tell us that. It tells us that angles are congruent, but side lengths are proportional. Now, it looks to me like most of you did fairly well on this top section, okay? On number 1, triangle ABC is similar to triangle XYZ. That tells us that angle C is congruent to what? Z. Good. They both come last in the name, so you should have angle C is congruent to angle Z. The second one here tells us that triangle FGK is similar to triangle RXW. Now this time we're dealing with side lengths. So notice the proportion is set up that same way. FG are the first 2 letters. RX are the first 2 letters. GK are the second 2. XW are the second 2. So what's missing? First and last. Good. FK on top, because that's from that triangle, and RW on the bottom. Okay, should be FK over RW. The rest of this section is that same basic idea. So we should have identified angle P as being congruent to angle P. We should have identified angle Z as being congruent to angle M. We should have filled in the blanks on this proportion on number 5. AG are the first 2 letters, so TX should go underneath that. XN are the last 2 letters, so GP should go above that. A and P are the first and last, so that should be T and N on the bottom there. Okay? Angle N should be congruent to angle P on number 6. Number 7, Q is first in the name of that triangle, so it should be congruent to angle A, which is first in the other one. And then the final proportion there, DE are the first 2 letters, AB are the first 2 letters. DF are first and last, so the bottom here should be AC. And then BC are the last 2, so EF should be on top there. Okay? Any questions on the top section? Check your answers, make sure they're right. Okay, that part we did fairly well on from what I could see. And then we ran into the next section, the proportions, and our brains just completely quit. Yep. Like, I don't remember, I've never seen a proportion before in my entire life, even though we've done them twice this year. Okay, which is worrisome. It's very concerning. So are we good here? Everybody all right? Okay. So then we go to solve the proportions, and I gave you a pair of proportions, and I asked you to solve them. Try to make them a little bit bigger here so we can see what we're doing. Okay, on number 9. Again, the idea here is that we are supposed to cross-multiply to create an equation. Okay? Some of you are cross-multiplying and creating a fraction. Don't do that. Okay? When we cross-multiply, we're doing 9 times x, or 9x, is equal to 27 times 16. Is that 432? 432? Okay, so it gives us 432 is equal to 9x. That's how proportions work. The means are equal to the extremes. Okay, I think it's section 3.1 was the first time we saw these, and we did a bunch of them in chapter 7 as well. Okay? Now that's a one-step linear equation. 9 times x equals 432. How do we find x?
Divide by 9.
Yeah, we just divide by 9. We divide each side by 9. And that gives us our answer. X equals, what's 432 divided by 9? 48? So x is 48. Okay? Now, they're not always that easy. Most of the ones you did in junior high were one-steppers, which is where some of you are getting that fraction from because you're used to doing cross, multiply, and divide every single time, right? But the second there's a plus sign in the proportion, like on number 10, that doesn't work anymore. And you got to stop looking for shortcuts. Okay? We do the same thing, though. 10 times x plus 22 equals 30 times x plus 2. I have no idea. Somebody's watching something in another room. Okay? That is an equation that everyone in here knows how to solve. What's the first step in solving that equation? Distribute. Very good. We do 30 times x and 30 times 2, 10 times x and 10 times 22. Okay, so 30x plus 60 equals 10x plus 220. Now we got an x on both sides, so what do? Okay, does it matter which one? Not at all. We do like to keep the numbers positive when we can, so I'm going to subtract 10x from each side. While we're at it, what else can we do? Yeah, we need to move the 60 at some point. We might as well do it now to get the x on one side and the number on the other, which gives us 20x equals, what is that, 160? And then what do we do next? Divide by 20 to get the x by itself. 160 divided by 20 gives us x equals 8. Okay, solving proportions should not be struggle bus material. That's very worrisome. If we had struggled on the next two, that's a little more understandable. But this, you guys have done this multiple years, multiple courses with multiple teachers, and you've done it twice already this year with me. So that's disconcerting. Okay. Are we good on these two? Still see some folks writing some stuff down. Do we have what we need? Okay, let's finish up with then we took this idea of solving proportions and we applied it to similar figures. Okay? So down here we said these pairs of polygons, they are similar. Find the value of x. So again, we need to look at this picture and we need to remember that the sides are proportional if these triangles are similar. And what we have to realize is that if we recognize the right angles, then each of our numbers here is paired with something on the other triangle. X and 9 are corresponding sides, right? 8 and 12 are corresponding sides. 10 does not correspond with anything because we don't know that number. You remember this? And we could take those and set up that extended proportion, right? X over 9 equals 8 over 12 equals 10 over whatever that is. Just like you did up top, right? Up there on numbers 2 and 5 and 8, you set up an extended proportion, yes? Now, since we don't know what pairs with 10, we don't worry about that one. We just set up the other one, the yellows and the blues. And we say x is to 9. Oops, probably should switch to the pen. X is to 9 as 8 is to 12. Because these are similar polygons, similar triangles, that has to be a true proportion. And then we solve it, just like we did up above. So what do? Cross multiply gives us 12x equals 72. Then what? Divide by 12. 72 divided by 12 is x equals 6. Okay? The means are equal to the extremes. And then we have a one-step equation, so we divide each side by 12. Okay? Now, before we go do the other one, let's talk scale factor. Let's do this one down here. What's the scale factor of these two triangles? What do we need in order to find scale factor? What numbers? We need one set of sides where we know both numbers. Do we have that? The blues, right? We know both of those. And now that we found 6, we know the yellows as well. Yeah? And it wouldn't matter which set we use. If we say the scale factor of the smaller to the larger, which number's bigger, 8 or 12? 12. So 12 goes on the bottom. The scale factor would be 8 over 12, except we need to reduce it. What's 8 over 12 in simplest form? So the scale factor of the smaller triangle to the larger triangle in number 11 is 2 to 3. And by the way, if we did that with the x and the 9, we still get 2 over 3. So it doesn't matter which side length we use, right? But we do have to know both numbers because we have to turn them into a fraction and then reduce it. On number 12, same idea. They are similar triangles. It says right there in the directions, each pair of polygons is similar. So we have to ask ourselves, what pairs with what? Well, between the 1 mark and the 2 mark angles, we've got x plus 15. If my pen will work right. Here we go. And 18. Those are paired. Okay, we've also got 40 and 30. Those correspond to each other. And just like the 10 over here, we don't have any idea what pairs with 36, but it really doesn't matter. Because we only need 2 to make a proportion. So our proportion would be x plus 15 is to 18 as 40 is to 30. Then we cross multiply and solve for x. Okay? So when we cross multiply, I told you when we did this before that I wanted you to write this out and then distribute. So we got 30 times x plus 15 equals 40 times 18, 720. Okay, we cross multiply. Again, the means are equal to the extremes. So 30 times x plus 15 is equal to 40 times 18, which is 720. Then we solve. What do we do to solve that? Distribute. We go 30 times x, 30 times 15, which gives us 720 equals 30x plus 450. Then what? Okay, subtract 450 from each side. That's what, 270? So 270 equals 30x, and then divide by 30 gives us 9. X equals 9. Okay, and then the scale factor of the smaller figure to the larger figure. We need one set of sides. Let's just use 30 and 40. Which number's bigger, 30 or 40? 40. So that goes on the bottom. So the scale factor would be 30 over 40, but reduced. So what can I do to reduce that? Both divisible by what? Good, by 10. Gives us a scale factor of 3/4. Okay? And that is how we do this stuff.